So density is how tightly something is packed. And you have several different options for units, and this is not an all-inclusive list, but for example, you could say, well, pounds per cubic inch. Notice that this is a measurement of weight or mass, depending on your perspective. This is a measurement of volume. Or let's go to the end, grams per liter. This is mass, this is volume. But sometimes it's going to be like people per square kilometer. This is area, so people per square kilometer. This is how tightly people are packed into one area. Or gigabytes per square millimeter, which would be a measurement of, or a way to indicate how efficient a hard drive is. All right, so let's just jump in with the problem. If a town has an area, I had to fix a mistake here, of 15.4 square miles and a population of 25,012, what is its population density? Okay, well, let's make sense of this. We're dealing with people and we're dealing with square miles. It would not make sense to say square miles per person. It would make more sense to say people per square miles. And when I say the word per, P-E-R, I'm really going to just divide. And that's all I'm going to do. Just divide to get what I need. Now, it doesn't always work like that because we're going to shift things around a little bit, but it works. So we're just going to do, in this case, we're going to do people divided by area. And that's it. So we have 25,012 people in 15.4 square miles. And I'm actually going to put that. So people here, and then square miles here. And when I do that, when I divide like this, then I'll be able to really see what my units are. So let's grab a calculator and we'll divide. And how far am I going to round? I don't know. So 1,624, let's do 2 decimal places, 0.16 people per square mile. Now I know you can't have 0.16 of a person. I realize that, but we're not dealing with exact areas, and this is an approximation. Okay. So the population density of Manhattan, well, let's just stop and think about this for a second. This was a population density of 1,600. This is a population density, highest of any county in the United States, at 66,000. So sometimes we have to kind of put things in context and compare. So here's a small town, and not a very big town in terms of population, and it's got this kind of sprawling rural area. Well, here we have a larger area, but we have an exploded population. Oh, sorry, we have a big population. We'll see in a minute exactly what it is. But here's the density. So in this case, we're going to do the same thing, but not the same thing. So what I really have is the density. And I don't want to say that this is always the formula, because now we're dealing with people per square mile or kilometer or whatever, square mile. But we're sometimes going to be dealing with gigabytes per millimeter or grams per liter, things like that. But in this case, the formula is density, which would be people divided by area. Well, how do you know that's what it is? Because it wouldn't make sense to say square miles per person, because normally you have more than one square mile per. You normally have more than one person per square mile, right? Unless you're in Wyoming. Anyway, so in this case, I'm just going to take this and plug in what I know. Well, I do know the density, and the density is 66,940 people per square mile. So 66,940, and that's equal to people. Well, I don't know what people is, because they said what is the population. We'll call that X. And if it covers 22.81 square miles, and now we just solve it. So we're going to just go to the next step. I don't know why I drew an arrow, but I felt like it. So if I was going to solve it, I'd multiply by 2281. So 66,940 times 2281 is going to give me, now we are dealing with an exact population here, so let's round to the nearest person. 1,526,901. Let's put some commas in and make some sense of it. That is 1.5 million people. That's a lot of people. Okay, so the population of Manhattan is about 1.5 million people. And again, I didn't use a decimal here. I did here because this is population density, which is an estimate, and things fluctuate. But we're dealing with the exact number of people. Okay, not a big deal either way. So we're going to compare the density of an aluminum cylinder. So this one's going to be aluminum, which is a pretty lightweight metal. Aluminum cylinder that measures 9 centimeters high, okay, has a radius of 5 centimeters. There we go. And it weighs 1908.52 G. That's grams. With a cube, we're going to compare that with a cube of solid copper. This is also solid, by the way. it was assumed. And it's a cube, measures 4 centimeters on an edge, so 4 centimeters, and then 4 centimeters, and then 4 centimeters. And I didn't put centimeters on here, but all of them are centimeters. You could. And it weighs 573.44 grams. All the units are the same, so I didn't throw a trick at you and be like, well, this one's in inches, and this one's in centimeters, and this one's pounds, and this one's grams, so there's none of that to compare. But what I do need to do is kind of look up here at my list of random stuff, like pounds per cubic inch. And I think that's kind of what I have in a sense. It's not exactly like that, but it's going to be a measurement of weight divided by cubic length. So this is going to be like mass or weight divided by volume. So in this case, the density is going to be, well, mass divided by volume. So I don't want to say that's always what it is, because here I said it was people divided by area. Well, over here I'm going to say, I'm just kind of saying it over on the side, the density, I'll call it D, is going to be the mass divided by the volume. And see, the fun thing is they told you the mass of both of these. They did not tell you the volume, though. So I'm going to have to figure out the volume. So before I go any further, before I pull this formula out and I use it here and I use it here, let's figure out what the volume of this thing is. Well, this one's a cylinder. By the way, I tried to make the shapes about proportional to their proportion. That's 5 and that's 4. And that's a little bit longer. Oh well, never mind. The volume of a cylinder is pi r squared h. So the volume of this is pi times 5 squared times 9. And we will call this what it is. It's going to be cubic centimeters. So pi times 25 times 9. Whoops, put a 6, that's a 9. And so let's do a couple decimal places just for fun. 706.86. And again, we're dealing with volume, so this is centimeters cubed. So cubic centimeters. So let's come over here and find this volume. And you could treat it like the box that it is, the right rectangular prism. And you could say, well, it's length times width times height, and that's fine. You could also say it's just like the length of the side cubed, which would be 4 cubed. So that'd be 64 cubic centimeters, because you'd have like 4 centimeters times 4 centimeters times 4 centimeters. So you multiplied centimeters 3 times. That's where cubic centimeters comes from. Just throwing that out there. Okay, so let's get really to the actual problem where we need to figure out the density and then compare them, because there's something kind of cool that happens here. We're dealing with the density of metals. So I'm going to have a density, I'll call it D, and it's going to be my mass. Now, we're dealing with the aluminum right now, and that would be 1908.52, so 1908.52. I'm going to put the grams in there just for fun. And then we're going to divide it by the volume, which is 706.86 cubic centimeters, and then we'll crank out an answer. Let's just come over here and start this one. We'll grab the calculator in a minute. And in this case, the mass, which would be 573.44 grams, divided by 64 cubic centimeters. Now, by the time I'm done, I'm going to say, well, this cube is so many grams per cubic centimeter, and this is grams per cubic centimeter. And again, it's a measurement of how tightly something is packed. So we might have some copper that's just like copper, like the molecules of copper, the atoms are just like, really tight together. And aluminum might not be the same way. Aluminum might just be a little looser, not as densely packed, and that just might be its property. And actually it is. I planned this problem so we could discover the differences between copper and aluminum. Both conduct electricity, for what that matters. This is rounds to about 2.7 grams per cubic centimeter. And so even though this one weighs more, this one actually is going to have a higher density, and you'll see it in a second. 573.44 divided by 64, and that is 8.96 grams per centimeter cubed. So what it really means is this. If I had the exact same volume, like if you take something that is the size of, let me reach and I'll find it, let me get it for you. If I had something that was the size of a die, just a regular die, and this one has the numbers on it instead of the dots, but that's okay. If I had this, and I had the exact same dimensions on both of them, you can hear the die rattling around here, there we go. And I have the exact same, let's just put the numbers, same numbers and everything, just for fun. You know, here's my aluminum and here's my copper, and it's the exact same quantity in terms of its volume, which one would weigh more? Well, this one would weigh more. It's like tightly packed, and this one isn't as tightly packed. And we can see that in these numbers right here. Okay, enough comparing the dice. Let's roll them and see if we should keep going. We should. All right, a box in the shape of a right rectangular prism. Okay, we don't have a picture on this one, but I think we can figure something out. A right rectangular prism is going to be, well, a box. A traditional looking box, not one of those odd shaped boxes that you would keep a triangular thing in. There you go. Elementary school, learned how to draw these things. Didn't do a very good job on this one though, did I? It's like a messed up refrigerator. Anyway, doesn't matter if you draw it or not. The point is we have a box, a traditionally shaped box. Measures 17.4 inches high, 17.4 inches high, 11.2 inches wide, 11.2, oops, left my decimal out, 11, well, it looks like 112. Let's fix that. So 11.2, and then 10 inches long. Can I switch those numbers? Sure, you can switch whatever you want. We're just going to multiply them all together anyway. It is filled with foam packing peanuts, you know, like the little styrofoam peanuts. If the density of the box and its contents is 0.0246 ounces per cubic inch, that's really not much. That's a small number. Because, you know, you've picked up empty boxes before that you thought they were empty, and then you open them up and there's all this like foam in there, right? Because there's so much empty space in it. And again, let's compare. If we're dealing with copper, you've got this metal and it's packed in there. You're dealing with foam packing peanuts. There's a lot of empty space, a lot of open air. So let's just keep reading. They gave me the density. They gave me some dimensions. So let's just kind of deal with this. The density was ounces per cubic inch. Well, if it's ounces per cubic inch, then what I really have is ounces on the top and cubic inches on the bottom, which I could call that volume, and that's my density. So what I really need to do is just fill in my numbers, okay? So let's go ahead and we'll do that, and we'll bring this down. And my density is 0.0246 ounces per cubic inch. And it says, what is the full weight? You could say, what is the mass, if you wanted to use that word. Within this context, I think we could interchange them. I'm going to call that ounces. And what I don't know, but I'm about to find out, is the volume of this thing. And the volume of it is just going to be super easy. So the volume is just going to be 10 times 11.2 times 17.4. Doesn't matter what order I multiply those in. I ran out of room. There we go. So here goes. 10 times 11.2 times 17.4, and I get 1948.8. 1948.8. Now, I should have used a variable instead of ounces. I think I will. If you want to keep the word ounces up there, that's fine. No one's going to hurt you. But I'm going to multiply these two together. And so x equals, well, whatever this is, times 0.02. So times 0.0246. And I got 47.94. Okay, 47.94 what? Well, ounces. There it is. Found out how many ounces this thing is, which, and if you really care to know, if we divided that by 16, that's how many pounds it is. It's right at 3 pounds. Just about 3 pounds. Okay, let's do one more, and this one's going to be a little bit tricky. Spherical bowling ball, which we think of them weighing a lot, and they have different densities as well. You can have two different bowling balls that look identical, same dimensions, but one can weigh more than the other, and it's a matter of density. It's not a matter of weight, okay? It's interesting. There are some bowling balls, I'm not making this up, there are some bowling balls that float. They have a density that is less than the density of water. Okay, a spherical bowling ball weighs 16 pounds. With a density of 0.05 pounds per cubic inch. All right, let's just stop right there. You know they're about to ask for, well, they're not. You're gonna need the volume. They asked for the diameter, but let's not even play that game now. Let's not go to the diameter. Let's just do this. And I'm going back up here, and I'm dealing with something like pounds per cubic inch. In a sense, it's really kind of like that. It's actually the same units. It's pounds per cubic inch. So my density is going to be pounds per cubic inch. Now, if you want to reword that and you want to say it's weight divided by volume, that's cool. That's fine. You can do whatever you want. My density is 0.05. The pounds is 16. And I don't know the weight. And I'm going to just call it X. I'm sorry, I don't know the volume. Actually, let's get really technical about it. I'm going to call it V. I'm not going to call it X. I'm going to call it V for volume. I need to know the volume of this thing. Now, you might say, well, let's just multiply by 16. No, you can't. You can't, because you're not dividing by 16. You're dividing by V. So let's cross multiply. 1 times 16 is 16. 0.05 V. It's 0.05 V. And then we will divide by 0.05. So 16 divided by 0.05 is going to give me 320. So the volume of this bowling ball is 320. Now, 320 what? Well, I'm dealing with inches. So it's cubic inches because it's volume. So now, here's the deal. What are they asking? They're asking for the diameter of a ball. Well, what shape is this? Well, it's a sphere. It's a ball, for crying out loud. What's the formula for the volume of a sphere? How do I even know I need to know that? Well, they're dealing with the sphere. You're dealing with volume. So I'm going to have to find the formula for the volume of a sphere. So here goes. The volume of a sphere, in case you ever wanted to know, and you've already learned it, is 4/3 pi r cubed. All right. So what I'm going to do is set this 320 equal to 4/3 pi r cubed, and I'm going to solve it for the diameter. Now, I don't have diameter. I have radius. Right? I'll find radius, and we'll get there. So let's find what we can first, and then we'll get there. So this is 4/3 pi r cubed. And we're going to multiply by 3. It gets that 3 out of the denominator. I'm going to do a lot of steps here all at once. 320. And then I'm going to multiply by 3. It's going to get the 3 out of the way. I'm going to divide by 4. You could say I'm going to divide by 4/3, but, whatever. Multiply by the reciprocal. We're going to divide by this pi. And there we go. So 76.394. And that is equal to r cubed. That is not equal to r. That is equal to r cubed. Well, I want to get r. I really want to get the diameter, but whatever. We'll deal with that. So let's take the cube root of that last answer. That undoes this cubed here. So we're going to cube root that. And in case you need to know what happened from here to here, we divided by 4/3 pi. If you really want to do it that way, you could. So r equals 4.243, just because I feel like it. Okay, so the radius of this is 4.243 inches. Now we're almost done, because they said, what's the diameter? Well, if I know the radius, and I want the diameter, I just multiply it by 2. So the diameter is 8.486 inches.